All right, so the last section in chapter 3, 3.4, and this is just further application of optimization. So it's continuing with optimization that we talked about in 3.3, but now we're just going to look at a particular application type problem. Now, before we get to that, I just want to review. We have dealt with relative extrema, and absolute extrema. So I just want to go over and remind you what you need to watch for on these. Relative extrema, of course, that's your relative minimum and maximum that we found with our first derivative, and that deals with open intervals. As opposed to absolute, of course, these are application problems and they have closed intervals, meaning the domain is only from 0 to 5 and whatnot. Now, in relative extrema, we use the first derivative to find the critical number, and then we looked at a sign diagram to see if it's increasing or decreasing, and then if we have a top of the hill and the bottom of the hill. With absolute extrema, we also need the critical numbers, but we also have to consider the endpoints. And then we take those endpoints and one or more critical numbers, and we use the original function to evaluate these values, looking for the greatest and least. Whereas here, we're looking for the top and the bottom of the hill. Okay, so that's just kind of a quick review, just to distinguish what we've done and the difference between those. Okay, now with today's, the first thing that we need to look at is we have dealt with, obviously our functions are typically f of x and what x is. And with what we've discussed so far, typically the variable x has been such as quantity sold. So what I'm talking about here is if we had defined x, or our input, to be the number of shirts sold or the number of shirts. So 5 would be, okay, if I plug this into a function, 5 shirts yields what profit? 5 shields yields what revenue? And that's where today's is going to be different. So now, whereas typically what your x would have been, now we're going to look at something that is called price changes. Businesses will look at this type to see if they made any type of price changes, meaning increase or decrease. Will it affect quantity sold? And of course, quantity sold is going to affect your profits. So price changes, we use this to analyze how price changes affect sales, which then, if your sales are affected, then that will or does affect your profits. So, price changes. That's the key to what we're looking at today, is how things change. So now, instead of X being a quantity such as the number of the shirts, X is now going to be the number of price changes. So like if I'm going to increase my price by $5, 2 would not mean $2. It would mean that I increased it twice. Okay. So hopefully when we do the example, it'll make a little bit more sense. Now, before we get to the example though, we need to talk through some formulas we're going to use. So the first one is the price function, which is P of X. We had P of X in 3.3, but what was different is in the previous section, they gave this to me. They told me what P of X was. Now we're going to have to determine what P of X is. We'll also be looking at the quantity function, which is Q of X. Now, because we're talking about price changes, you have to be sure that when you are finding these functions, you must consider the changes that can occur in the price and the quantity. And again, when we actually look at an example, hopefully that'll kind of all come together for you. All right, so also we saw and talked about previously that the revenue function is the price function times quantity, which previously that was just X, but now we're going to actually have a function for this. So it's your price function times your quantity function. Your cost function, if you remember, it was cost per unit plus fixed costs. This right here is going to be your cost times Q of X. So you have to be careful on that one. And then of course we know that profit is revenue minus cost. So we are going to have to be using all of these and applying all of those. So have those handy as we go through this example. All right, so here's the example that we're going to look at. So there is a bike store, can sell 20 bikes per week. Sorry about that green line. I don't know what that is. Oh, per week. I'm going to do a comma because I didn't want a period. At $400 each. Now, period. For each $10 price reduction, you can sell 2 more bikes per week. Each bike costs $200 each. Lots going on. Now, what I want you to pay attention to as well is looking for my other highlighter. We're dealing with price. So if you'll look, there's prices of $400 in that, $10 in that, and $200. We're talking, well, actually 200 is cost. Quantity, you're looking at 20 per week, and you're looking at 2 more bikes per week. So those are kind of how you need to distinguish your numbers. Now, as I said, that the key difference here is what your X is. Typically, we would think X is your number of bikes. Okay, if I sell 20 bikes, what kind of revenue am I going to get? But we're not looking at X is equal to the number of bikes. X is going to be the number of $10 reductions. How many times am I going to reduce the price of the bike? All right. So the first 2 functions we want to create are your price function and your quantity function. So P of X, this is your price. Be careful, it doesn't deal with 200, that's your cost. All right, so price, all right, so what we're looking at here is the price is $400 each. Okay, so this would start out as $400. Quantity, I have a different color pen and I do it. So quantity is selling 20 bikes per week. So this would be 20. Now, typically it'd be nice if we could stop there, but I just want to remind you that you must consider the price change as well as the quantity change. All right, so the price was $400 each, but for each $10 price reduction. So each $10 price reduction would be, it will reduce by $10 for each reduction. So at 0 reductions, the price of the bike is $400. If I have 1 reduction, then we would have 400 minus 10 times 1, so it would be 390. If I had 2 reductions, I'd have 400 minus 20, so it'd be 380. So that's kind of what it's talking about as a $10 reduction. The quantity is, we're looking at 20 bikes per week, but what happens when we sell 2 more per week? So this would be plus 2 more. So this is if I have 0 reductions, I sell 20 bikes. If I have 1 reduction, I'm going to sell 22 bikes that week. If I have 2 reductions, I'm going to sell 24 bikes. So you can see as the reductions occur, you're going to sell more bikes each week. All right, so this is my price and my quantity function. So now we're going to go through and we're going to find the revenue function. And remember that that is P of X times Q of X. So that is 400 minus 10x times 20 plus 2x. So I'm going to FOIL that. So 8,000 plus 800x minus 200x minus 20x squared. Combine like terms, so I get 8,000 plus 600x minus 20x squared. So here is my revenue function. Now we're going to find our cost function, which is cost per unit. And if you'll pull that from what we did on the previous page, that is your cost times Q of X plus any fixed costs. So our cost now, so I have to come back up to the original because the 400 is what the price was, but the cost is $200 each. So the owner of the bike shop had to have a cost of $200. So it is $200 times Q of X, which is 20 plus 2X. Now, here's the thing. This particular problem did not mention any fixed costs. So just pay attention to WebAssign. You very well might encounter one that says it has a fixed cost of $1,500. This problem didn't have one, so that would just be 0. So my cost is 4,000 plus 400X. So there's our cost function. So then the other function that we need to find is our profit function, which we know is revenue minus cost so it's going to be 8,000 minus 4,000, 600 or 600x minus 400x, and then minus 20x squared. So quite a bit of work involved before we actually answer any questions, but these are all the functions as well as including these that we're going to need or possibly need. So I wanted to be sure and show you how to do each one. All right, so now I'm going to look at some particular questions to answer. Find the price to maximize profit. All right, so of course, what you got to look at first is go, okay, this is talking about profit, because remember it could say profit, revenue, cost, but because it says profit, then I know I want to use and consider the profit function. So I'm going to rewrite that from what we had found earlier. And then to maximize that, we know, hey, I need to find the first derivative. $200 minus 40x. And then to find the maximum profit, we need the critical number. So we're going to set this. Yeah, checking that that shouldn't be 2,000, but we're correct. All right, so I'm going to set this equal to 0, and I'm going to go ahead and add 40x to both sides, divide both sides by 40, and I get x equals 5. All right, so this right here is our critical number. This is where you need to be careful. Typically, we would go, oh, that means 5 bikes, but that's not what we're talking about here. This is your number of price reductions. Which means, of course, this is our critical number, that to maximize profit, we'll do 5 price reductions. Okay, that's where you need to be careful. Now, we're going to go ahead and look at the second derivative. Just to confirm that it is concave down. So that means that the second derivative would need to be less than 0 or a negative number. So if we find the second derivative of this, we get negative 40. So sure enough, that proves to me that it's concave down. So we do know that this is a maximum. Now it said find the price. So we're going to go back to the price function. So the price function was P of X equals 400 minus 10 times X. So the price of the bike is $400, but we're going to subtract 10 price reductions. So this tells me that to maximize my profits, I need to sell the bikes for $350. Okay. All right. B, find the number of bikes. So now we're talking about quantity sold each week at that price. Okay, and again, here, number of bikes tells me we're talking about quantity. So we're going to take the quantity function, which was 20 plus 2x, and we're going to have 5 price reductions. So 20 plus, because we sell 2 more bikes for each price reduction. So we get 20 plus 10. So 30 bikes. So he or she will sell 30 bikes a week if they do that price reduction. C, what is the maximum profit? So we go back to our profit function. X, how many price reductions? 5 of them. $4,500. So obviously the key on this is being sure that you are careful and intentional on setting up your formulas. If you can get those formulas straight, you should be fine.